select the major product of the following reaction. So in this reaction, we can see that we have a benzene. A benzene ring is the core part of our molecule. We've also got a methyl group, and we have a hydroxy group. And if we look at our reagents, we are adding just molecular bromine. So molecular bromine on its own will not typically react with a benzene ring, but this benzene ring happens to have two substituents that are both electron donating. And so that is why we do not need the Lewis acid catalyst here. So no Lewis acid catalyst required. And that is because the ring is activated. And so we know that the ring is activated because what we're seeing is that we've got two electron donating groups on the ring. Okay, so in addition to activating the ring for substitution, and the substitution we're doing is a bromination. This is an EAS bromination reaction. So then the question is, where are we doing that substitution? Where is the bromine going to add on the ring? So we need to take a look at the directing effects of both of these groups. So we have the methyl group and we have the hydroxy group. And so if I take a look at the hydroxy group first, these are both donating groups, so they are both ortho-para directors. So this is an ortho-para director. So we want to look at the positions ortho and para. So para, we've got the methyl group, so we can't substitute there. Ortho, here and here. So the hydroxy group is going to direct the incoming bromine to these two ortho positions. And if we look at the methyl group, that's also a donating group, and it is also an ortho-para director. And so if we look at the positions that are ortho and para to the methyl group, well, at the para position, we already have a hydroxy group, so we cannot substitute there. Ortho to the methyl group would be here and here. So these two groups are pointing to different spots on the ring. So now we need to look at their activating properties. A methyl group, any alkyl group, is very weakly activating. If we look at the hydroxy group, because you've got those lone pairs of electrons that could donate into the ring through resonance, this is a strongly activating group. And when you've got one group that is strongly activating, one that is weakly activating, your group that is strongly activating is going to be the one that's going to dominate. That is going to be the one that will direct your incoming electrophile. So E+ as an abbreviation for electrophile. And so when we take this ring and we react it with molecular bromine, we are going to add a bromine either to here or here. The ring is symmetrical, so it does not matter which position we pick. So we would have the two substituents that we started with, and we're going to have a bromine, and I'm just going to put it on this ortho position right here. And if we take a look at the options down below, we can see that that is option A.